Okay, the total cost in a certain month is 112,720 Danish krona. Draw on the same axis the graph of the line representing a cost of this, as well as the equation modeling the total cost. So we need to draw a couple things here. X and Y axis, I'm going to go ahead and make sure that it's all on the positive because we're not going to have a negative amount of bouquets and we're not going to have a negative cost in this case because we know that our Y-intercept is positive. Let's go ahead and go up by 2,000s because we need to get up to 2, 4, 6, 8, 10. Actually, let's go up by 1,000. 2,000, 3,000, 4,000, 5,000, 6,000, 7,000. This is our X value, which is number of bouquets. Please remember the importance of labeling your axes. I know it might seem a little bit redundant, but the EIB does mark you off if you don't label your axes. So, I mean, get in the habit of it now because the EIB will mark you off if you don't. So remember that your scale always needs to be consistent. Here, I would like to go up by, I need to make sure I get up to, let's call that 115,000. And we have 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to do 115,000 dividing by 8 to see like, okay, how many units could that be? And it looks like close to 15,000. So I might try doing that and see how that works out. I'm glad I'm doing this in pencil. $45. Yeah. And then 125,000 and then 140,000. No. This should be 75. And then this guy will be 90. And then okay. That was stressful. So then this is cost here on the y-axis. Okay, so we first want to graph the cost of this. If C is equal to 112,720, remember that that's kind of like saying y equals that number because C is now our new y. So that means it's going to be what type of line? When it's y equals a number, what type of line is it going to be? Remember, if it's y equals a number, it means that no matter what, we're always going to be at this same height, right? If y is how tall we are, we're saying we're always at this height. So that's this idea of a horizontal blockade of a line, so a horizontal line. So y equals a number is always a horizontal line, which means that this needs to be a horizontal line. It needs to be somewhere between here. Halfway between is like 13. So this is slowly under or slightly under. I'm going to do it in a different color. And this is C equals 112,720. And then now I need to actually graph my other guy. I know that my y-intercept is 6,000, which is pretty actually far down here in terms of my graph. 6,000 is just under, maybe a little bit under. Halfway there. once we're dealing with big numbers like this, 6,000 is kind of a guess in terms of its spot, but take your best guess here. And then trying to think of another number, like maybe if we plug in 2,000 into the equation, we can find another point and then be able to draw our straight line. So if I plug in 2,000 into my formula up above, 72 times 2,000 plus 6,000 is 150,000. Which is off our chart. So then let's try instead 72 times 1,000. And that's more on our chart. So at 1,078 is going to be maybe like right here. There we go. Thank you for bearing with me as I problem solve through this. This is the process that happens as you're making lines and making equations and graphing things, is you're kind of like puzzling it out and saying like, okay, and pivoting, I guess, with the moments. Okay, now this is our equation. C equals 6,000 plus 72x. So it says all we had to do was graph it. We probably graphed it for a reason. So then the follow-up question is find the number of bouquets made if the cost is this. So we could set our equation equal to this and use numerical solve, or if you have a TI Inspired, this is, or sorry, a TI 84, this is also always an option if the numerical solve doesn't work for you, is that you could graph one equation and then graph y equals the thing you would set it equal to, and then find where those intersections are. So if you're trying to solve for an equation and you don't have numerical solve, you can always take each side of the equal sign and put it in for y equals, and then find where that intersection is. So here is our intersection, and we can write some note to ourselves since this is our notes. That's just the intersection. So this is 112,720 equals 6,000 plus 72x. I think it's actually easier in this case to actually just solve. So 112,720. Go ahead and tell me what the answer is on your own. So we should get a decimal that looks like this. So we can't have a decimal of bouquets. We need to talk about whole bouquets, but we need to think about this in regards to the context of the problem. Now, we're not always following the rounding rules. We need to make sure that we're rounding appropriately. So if the cost is this, if we round down, our cost is going to be less. If we round down from this number, we're going to be below this line. But if we are at this cost, that means that we need to be at this point or above it in order for us to have hit a cost of this. So if we round down to 82, we won't have hit that cost yet, which means that we won't have satisfied the problem. So in this case, we need to round up, even though our rounding rules don't tell us so. So it's 1,483 bouquets. Okay, let's move on to our last problem. Novo Rasco de Opera had only 50 social housing units when the new social program started. Since then, it has been adding new social housing units at a steady rate. Now, 17 years later, the town has a total of 322 social housing units. A few things. We know that this is a line because it says that they are increasing at a steady rate. That means a constant rate of change, which I'm sure you've heard before in previous math classes in reference to a linear equation. It's okay if you don't remember, but you've definitely heard it. A constant rate of change is a linear slope. In other words, it's saying that your slope is always the same, which on a line, it always is. On a curve, maybe not, right? Your curve, the slope will change as it's curving around. Versus a line, your slope will always stay the same. So it's constant, and your slope is the rate at which you change. Find the increase in social housing units per year. So we need to find the slope.